Shazatters, what's up again? All right, so I'm just pounding out some stuff right now. So we're going to do question 102 of the Form B of the 2022-23 SHSAT Handbook. Yeah! And then we're getting closer to finishing all of the math. And then I have left the SHSAT 9 questions and some of the grid-ins. Let's see how I can progress past here. All right, so 102, let's jump into it. These are the constant or proportionality questions, and we're going to talk about how to solve them and also usually how to identify them, okay? The graph shows the relationship between a graph. It's not showing us the graph. The relationship. It doesn't say proportional. If it said proportional, then we know that it's probably referring to something involving the constant of proportionality. So let's see where this goes. Between the number of gallons of water Y that has been added to a tank and the number of hours X that has been the water has been added to at a constant rate. Ah, there we go. So there is the constant of proportionality here. So let's actually mock this up, if you will, just so we have a visual. That's always important. They did not give this to us, but we're going to give it to ourselves. And what they did was they described Y first, and then they described X. So this kind of table flip gets a lot of students. So this is X, this is Y, and they're telling us that X is the number of hours, and that Y is the number of gallons. Okay, since it's a constant rate, all right, the graph, if you will, let's look at let's get the 324 here. So let's assume, because X is going to be 3 and Y is 24, 24 is going to be there, 12 is going to be here, 6 is going to be here, and 3 is going to be here, and it just breaks down to that. So the x-axis is kind of worked the same way, where that's about 12, that's about 6, and that's about 3, okay? So 24 is going to be right there, okay? So that's 3, comma 24 as a coordinate geometry, all right? So if it's at a constant rate, that means at 3 hours, it's filled up 24 gallons. It also means with no time, there's no water. So it's starting basically from here. That's our line. So let's try to mock that up as best as I can do here. Like that. Okay? So that's our line. That's our line. That's what we're exactly what we have going on here. All right, so let's reread it to make sure it's making sense. A graph shows the relationship between the number of gallons, that's the y-axis, right, that has been added to a tank, and the number of hours that water has been added to the tank at a constant rate. So the water is going into the tank consistently at a constant rate. What does the order pair 324 represent? We can cover that up. And it's 3 hours yields 24 gallons. All right. So let's look at the choices. E, 3 gallons of water was added in 24 hours. No, that's the opposite, right? And 24 hours is, if this is 12 right here, then 24 is over here. So 24.3 would be this point here. Okay, we're over there. So it's definitely not E, and you can logic it out. That's not what that's saying, so it's not E. Okay, F, 3 gallons of water was added per hour. No, if we get 3 gallons of water, okay, is going to be over here. I'm not convinced that's 1. So that's not what it's talking about there. In fact, we know from this, if this is 0, 0, we know that if we were to compute the slope of that, we would get 24 minus 0 over 3 minus 0. And that's just 24 over 3, and that's 8. So it would be 8 gallons of water per hour. All right, so it's not F. Okay. G. 24 gallons of water was added in 3 hours. That's what it's saying. In 3 hours, read the axis, 24 gallons. Booyah, we got it. Okay, and just out of process of elimination and bringing things to fruition, just in case we misunderstood a choice, we're going to use process H anyway. 24 gallons of water was added per hour. So 24.1 would be all the way down here now, this point right there. Okay, that's not what it's talking about either. And reason it out, right? That doesn't make sense considering what we thought about this here. All right, so H is out the window as well. So what we're doing is we got the point they gave us, the 324. We drew it, right? So that's this dot. I'll make it larger. It said it was at a constant rate, so we knew it went through 0, 0. We drew the line, and then we just reasoned out all the choices that they're giving us, right? So we have basically if y is equal to kx, then what we have is y is equal to 8x, because we just computed what the constant of proportionality would be in this case. All right. And if we, given the way I drew this was not right, because I actually scaled the y to 24 and I scaled the x to I ended up putting 12. I made a mistake there, but so it's hard to read the graph properly. But what 1 basically should have been 8. So if I break this down that's further, I should have ended up basically there. It doesn't quite line up with the way I drew it, but that would be the scenario, right? So in other words, if 3 hours gives 24 gallons, then 6 hours, right, would give double that, would give 48, and we can just plug it in. For the 3, it's 8 times 3, and for the other, it would be 8 times 6, right? Once we know our constant of proportionality k, we should just go happily forward with that. All right, so that's 102. What's the next one that's the constant of proportionality? 104. Okay, so this one, they actually do give us a graph. They don't tell us the points, but they gave us 0, 0. See the dot there? Okay, they gave us 1, 3. And they gave us 3, 9. So what we have is a line here. Like that. All right. Don't know if I drew that perfectly, but yeah. And it also means the 2, 6 is going to match. So let's just go through it. We have 3 points on here. We connected the line. We don't know what else is going on here, but we're making sure this was x, this was y. These are in units of 1. These are in units of 1. We don't know what they're measuring here, but I guess we don't care for what they're asking us for. And ignore this. This was a solution to another question. The graph shown below represents a proportional relationship. We already know that because it went through 0, 0, okay? And it plots out. Because if we do that same thing with the y equals kx here, right? In the same way we calculate the slope, we could have taken anything here. So if we have the delta y over the delta x here, which is our rise over our run, what we get is 3 minus 0 over 1 minus 0. We get 3 over 1, so we get the constant of proportionality is 3 then. And we can confirm that because basically 1 matches 3 here, 2 matches the 6, and 3 will match the 9. Okay, so they all jive through that. We could have taken some of the other points though, the same way I could have taken the 3, 9 and done the delta y over delta x the same way and got 9 minus 0 over 3 minus 0, and that's 9 over 3, and that's equal to 3. And we could have even done that between these 2 points, all right? And we would have gotten 9 minus 3 over 3 minus 1, okay? And we get 6 over 2, and that's also equal to 3. So it doesn't matter as long as the line is a proportional relationship, a constant of proportionality. And again, these are our clue-ins. It's telling us there's a proportional relationship. We also drew it to confirm it. And then it's asking what is involved in that proportion, and that's the constant. So that's what they're asking. So when you see terms like that we're seeing in these questions, constant of proportionality, unit rate even, proportional relationship, not just a relationship, a proportional relationship. It has to say that. We know that the constant of proportionality can kick in at that point. All right, so the answer to this would be G. All right, the next one that involves that's 104, is 105. Okay, so the distance an eagle flies is proportional. So the distance is proportional, is in proportion to the time the eagle spends flying. That's basically what it's saying, because it's telling us the distance is proportional. So there's a constant of proportionality there. So if you divide both sides by f, that kicks out. So that's where I got this from, okay? I mean, if we want, we can stay with the d equals k times f. And by the way, this is really distance equals rate times time. Right? Because the distance is to the time flying. So I used f, but I could use t. It didn't, not a big deal. An eagle flies 90 miles in 3 hours. What is the constant of proportionality for this relationship? All right, so what they're asking us is to do that 90 miles, right? If we map this here, 90 miles over the time flying is 3 hours, and we get the 30. Okay, so this one wasn't too bad either. So key is realizing this constant of proportionality, and look at how many times, especially in the previous video, I mentioned D equals RT kind of stuff. It's not so much that you must know that formula, but that you were getting the relationship right. So there's D equals KF. Let me change this for a second, the color. The distance of the eagle went is proportional. It's in proportion, right? So how is it in proportion? So if the flying time goes up, then the distance goes up. If the flying time goes down, then the distance goes down. And that's based on that the eagle flying consistently. Now you may argue, eagle can't fly consistently. That's not what the problem says. The problem says it can. So you have to go with that, all right? So that one wasn't too bad. And that's basically what we're doing. We're just doing, getting a unit rate, right? If D equals RT, then R equals D over T. And again, that's what I'm drawing here using what they're saying. So they want the unit rate. So if it's 90 per 3, gives us the 30. The unit rate is going to be 30. All right, that's all they're asking. So that's 105, again, constant of proportionality. And the last constant of proportionality one was, I believe, 109. And this one gets a little elusive because of the phraseology and stuff they use. So although I've probably categorized the other ones as kind of easy SHSAT questions, if you will, in the context of the SHSAT. This I probably would not. All right, so let's see what's going on here. A farmer has 100 apples, and he will eat 2 apples per day. So that's a rate, 2 apples per day, right? That's a rate. Is there a proportional relationship between the number of apples remaining and the number of days that have passed? Ooh, that's a good one. And then they give us all these ugly answers here to try to kind of compute out of that. So we're trying to shoot for, again, is the y equals kx stuff. But it seems like this because there's a rate mentioned here, and you guys know that if you're eating 2 a day, in other words, on day 0, there's 100 apples. Okay, on day 1, the person, let's make this a table. I'm not using subtraction there. So this is the day, and this is the number of apples. Okay, on day 1, the person's eaten 2. So now they're down to 98. Okay, on day 2, the person's starting with 98, and they're eating 2 again, and now they're down to 96. On day 3, they started with 96, they eat 2, and they're down to 94. So we can argue this is going down consistently at 2 apples per day. All right? So but that's why this gets elusive. So is there a proportional relationship though? Can I do this y equals kx based on this table here? Right? That's the gotcha here. And it turns out we can't. We can't because, and this is a weird answer, it's because it doesn't go through 0, 0. It starts at 100. It starts at 100. So it never gets to the 0, 0 capability. And that's an insight, that's a ramification, a consequence, an artifact of constant proportionality. If you notice in the other examples I talked about, including other videos, but certainly this one, I'm mentioning it's going through 0, 0. That was when, I think, when we talked about 102, when I graphed it as something. And then when they gave us the second 104, I think it was, where they actually gave the graph with the 3 points, it was important that one of those points went through 0, 0, because it makes sense that if we had the one case where the constant was 3, right? Well, if there's no x's, that would be 3 times 0. And we get out of that 0 equals 3 times 0, or 0 equals 0. That would be a truism in that case. But on the case of this apple situation, that's not something that's going on, because on day 0, there's 100 apples. All right? So we can't get that. That's not what's going on here. And basically, this is really y is equal to minus 2x plus 100. All right, that's our linear equation for this apple situation. So with all that in mind, let's try to beat up the answer choices. Farmer has 100 apples. He will two eat apples a day. Is there a proportional relationship? We think it's no between the number of apples. So that let's work through the yeses just to be sure. Yes, because all the values and the relationship are even. Well, a proportional relationship does not have to involve even values. So that just goes out the window. That's silly. In other words, this 98, 96, 94, 100, they're all even. That has nothing to do with it. And then yes, because the number of apples is decreasing at a constant rate. So it is going down by 2 apples per day. But that alone isn't sufficient, because it has to match this y equals kx thing. And we notice it has the plus 100 here. So k might be minus 2, but we started from plus 100. So for that reason, you're out the window, bro. No go. All right. So now that we know it's no, and we believe it's because of what B is saying, and B is the answer. But what's going on with A says no, because the relationship does not include 99. So this is almost similar to like them saying even. Um, if we were to graph it, the 99 would be stuck in there, right? Because if we were to graph it, it's starting at 100 and it's going downward in a downward spiral somehow. So at some point, we could actually identify where the 99 was. And it would basically be at 1.5, right? If 98 is day 1 and 96 is day 2, then obviously like at noon, if you will, on the middle of at noon on this between the first and second day would be the 99. So even though 99 doesn't get mentioned in this algorithm here, the -2, -2, -2, basically it's the day before a -2, right? Even though it doesn't get mentioned, that alone is not a logical connection between how the linear relationship is going to work here. So don't get wrong. There's a linear relationship. It's happening. There is a constant rate of the apples decreasing per day, but it's not a proportional relationship. So it's not this either. All right, and that is 109, and we're done with all those questions as well. There's about let's see, I categorize it 1, 2, 3, 4, 5, 6, 7. There seems to be 7 problems I skipped because they don't quite fall into a category. A bunch of percents and some more arithmetic questions. So I will do those on another step, on another video. All right. Please like, please subscribe, smash the like button. Come on, let's do this. And hit me up at GregsTutoringNYC@gmail.com. Yo, peace. Bye.